Welcome to Math with Mrs. Bibb. Today's notes are about radicals. If you'll please look up these definitions in your textbook. Those definitions can be found in Chapter 9, Section 1. We have already simplified radicals in previous videos, so I'm going to assume that you have remembered how to simplify those radicals. I am not going to make the factors on the side. I'm going to talk through the perfect squares. So as I look at number 1, I know that 4 is the biggest perfect square found within 24. So I'll rewrite the square root of 24 as the square root of 4 times the square root of 6. The square root of 4 is 2, and the square root of 6 I cannot simplify, so the square root of 24 is 2 times the square root of 6. For number 2, I'm going to multiply negative 1 times the perfect square that's in 48. 4 is in 48, 4 times 12. But 12 still has a perfect square. So hopefully you can see that 16 is the biggest perfect square for 48 times the square root of 3. This product is still equivalent to negative square root of 48. Next I'm going to take the square root of 16, and negative 1 times 4 is negative 4 times the square root of 3. For the next one, I think it's 81, 81 times 2. I'm going to rewrite this as the square root of 81 times the square root of 2 times the square root of g to the 6th power. I want even exponents on my variables. If I don't have an even exponent, I'll rewrite to have an even exponent. Then I'm going to take the square root of the things that I can. The square of 81 is 9. I can't do anything with the square root of 2. And the square root of g to the 6th power is g to the 2nd power. Let me rewrite that really quickly. You will understand, especially after all that we've been doing in class. The square root of g to the 6th can be rewritten as g to the 6th divided by 2 as a rational exponent. Oh, and I just made a mistake, so you don't have to tell me about my mistake I made. I just found it. 6 divided by 2 is 3, so that's g to the 3rd. So that's how you can do those, is divide those exponents. Divide the exponent by the root. And so let me finish that. 9 times the square root of 2 times g to the 3rd is 9g to the 3rd times the square root of 2. For the next one, I'm thinking it's 64. 64 times 8, which there's another perfect square in there. Is that 256 maybe? 8 times 4 is 32. 8 times 6 is 48. Yes. So I bet it's 32. 32 times... Not 32. 256. I don't know what I'm thinking. I don't know what I was thinking with 32. 256 times 2? 12, 11, yes, 256 times 2. So negative 1 times the square root of 256 times the square root of 2 times the square root of, I have h to the 7th power. I want to have an even exponent. So I can rewrite h to the 7th as the square root of h to the 6th times the square root of h, because 6 plus 1 is 7, so that is still equivalent. Then I'm going to take the square root of the things that I can. Negative 1 times the square root of 256 is 16 times the square root of 2. The square root of h to the 6th is h to the 3rd power times the square root of h. And now I am going to multiply everything that's not under a radical, and then I'm going to multiply everything that is under a radical to get my final answer. So my final answer is going to be negative 16h to the 3rd. Oh, I left off my... That's an h, isn't it? See, there's another mistake, but I caught it. Yeah, that's the h. So then negative 16h to the 3rd times the square root of 2h. That's my final answer for number 4. Now I'm looking at number, how did I go from number 4 to number 9? Let's just skip some, it'll be okay. And if they're on another page, I'm so sorry that I mixed this up. Now I'm looking for perfect cubes. I'm thinking that 27 is the number I need. Remember, you're thinking 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed, 7 cubed. Is that, it's 49 times 7. 9s are 63, 28, 343. I think that's 9 cubed. Is that right? 81. No, I'm looking at number 10. 81 times 9. Yes. Okay, so anyway, I'm going to rewrite number 9 as the cube root of -1, just so I can take care of that, times the cube root of 27 times the cube root of 5. The cube root of -1 is -1. The cube root of 27 is 3. And the cube root of 5 I can't do anything with. So -1 times 3 is -3 times the cube root of 5. And then number 10, the cube root of 729 is 9, because 9 to the 3rd power is 729. Number 11, -1 times the cube root of, I'm thinking it's 64. 64 times the cube root of 3 times, I need an exponent that's divisible by 3. So the cube root of x to the 3rd times the cube root of x to the 2nd. Now if I were to multiply all of that, I would get x to the 5th power. So I have -1 times the cube root of 64 is 4. I think I left off my little root symbol here. Times the cube root of 3 times the cube root of x cubed is x to the 1st power times the cube root of x squared. Let me highlight again. I am going to multiply everything that's not under a radical, and then I'll multiply everything that is under a radical. So it looks like my answer is -4x times the cube root of 3x squared. That's my answer to number 11. Okay, so square root. How to simplify square root. Please notice that here you can rewrite a fraction under a square root as 2 separate roots and then simplify. You can also do this. I want you to remember if you have 32 over 50 in a square root, or if it was written this way. And you notice that they're both even. You could rewrite it like this, simplify both of them, and then break it apart. Oops. See, I made a mistake. I'm trying to get good at catching those so I don't make so many silly mistakes. And then the square root of 16 is 4, and the square root of 25 is 5. So my advice is make sure to reduce if you can. If you notice that you can reduce the two numbers, reduce those numbers and make your life easier. So that's the one thing about the quotient property of square roots that I want you to know. Okay, next. So let's look at these examples. Number 5, the square root of 25 64ths. Remember, you can rewrite that as, the square root of 25 over the square root of 64. The square root of 25 is 5. The square root of 64 is 8. That's my final answer. The next one, that's a negative, so it stays out there. The square root of 6 over the square root of 49. I cannot simplify the square root of 6, so it's going to stay negative out here times the square root of 6. But I can simplify the square root of 49, that's 7. The next one, negative square root of 196 divided by square root of r to the 4th. So that would be negative 14 divided by r squared. 196 is a perfect square, and r to the 4th power is a perfect square. For number 8, I'm going to rewrite that as the square root of 49 times the square root of x squared times the square root of x. And I only did that because this was an odd exponent. And then I'm going to rewrite 64 y squared as the square root of 64 times the square root of y squared. So I have 7x times the square root of x, and in the denominator I have 8y. That's the answer to number 8. Now we're going to do the product property. Same sort of concept. If you have two things multiplied, you can separate them and multiply, or you can put them together to multiply, as long as their root is the same. You could not multiply this. That is not, oops, now you can multiply those, that's the cube root of 6, but you cannot multiply this. The answer to that is the cube root of 2 times the square root of 3. You would have to rewrite with exponents and then simplify if possible. We won't do number 12, so you can just scratch it out if you'd like. Now we'll go on to 13 through 16. We're going to simplify. And when I look at number 13, I notice that both of these are divisible by 5. So I'm going to rewrite as one radical. I'm going to divide them both by 5. So that would be the square root of 3 over 100. I'm going to separate that again into the square root of 3 over the square root of 100. And then that just gives me the square root of 3 over 10. So you're always looking to reduce and then find perfect squares if you can. For the next one, I notice right now that I can reduce these as they are. So that would be the square root of 4 over 50. But they will reduce again, so I'm going to divide them both by 2 again. So 2 over 25. And then I can rewrite as the square root of 2 over the square root of 25, which is the square root of 2 over 5. That's my final answer. Now, I am going to rewrite this as one radical. I don't think my numbers will reduce, but my variables will. So I am going to reduce the x's. The y's will cancel out. Then I'm going to rewrite that as the square root of 3x. And then 80 is 16. The square root of 16 times the square root of 5. So the square root of 3x in the numerator, and then 4 times the square root of 5 in the denominator. Now, I believe they want me to rationalize here. Let me just, I don't think I've mentioned this in class yet. It's not proper to have a radical in the denominator. So you have to get rid of that radical. The process of getting rid of that radical is called rationalizing the denominator. So to get rid of this square root of 5 that I have highlighted green, all I have to do is multiply my numerator and denominator by the square root of 5. The square root of 3x times the square root of 5 is the square root of 15x. I have my 4 beside of this green highlighted square root of 5. I'm going to bring it over. The square root of 5 times the square root of 5 is the square root of 25. Let me bring this down here. So I have the square root of 15x over 4 times 5. Oops, that's not writing down there. I tried to write times 5. So that 4 times 5, I have the square root of 15x over 20. And that's my answer to number 15. And I cannot reduce something that's under the radical and something that is outside the radical. So I cannot reduce the 15 and the 20. Okay, now let's look at the next one. I am going to reduce the cube root of 16. The cube root of 8 times the cube root of 2. So 8 divided by 2 times the cube root of 2. I'm going to say for cube roots, we're going to stop there for now. That's getting way too complicated for Algebra 1. So for cube root, we're going to leave that there. We really should rationalize, but we're going to leave that there. Okay. Oh, I need to reduce, though. Whoopsie. Let me do reduce that. I'll take away. I'm circling that. So I'm going to have 8 and 2 have a common factor of 2. 8 divided by 2 is 4. And then cube root of 2 in the denominator. We're just going to leave cube roots that way for now. Okay, let's go to the next page. Now notice I have a radical in the denominator. I have to get rid of that radical in the denominator, but this radical is connected to another number because we have a binomial. To get rid of this and this, we multiply what's called the conjugate. And that's where you simply change the middle sign of your denominator. I'll show you what I'm talking about. So to simplify 5 divided by -3 minus 3 square root of 3, we multiply the numerator and the denominator by the conjugate, -3 plus 3 times the square root of 3. Now I'm going to distribute in the numerator. Actually, I'm going to show you what that looks like. That's 5 times -3 plus 3 square root of 3 in the numerator. Then in the denominator we have -3 minus 3 square root of 3 times -3 plus 3 square root of 3. I'm going to distribute in the numerator. So 5 times -3 is -15. 5 times 3 is 15, so plus 15 square root of 3. In the denominator, I'm going to have this. I'm doing -3 times -3 plus 3 square root of 3. And then I'm going to do -3 square root of 3 times -3 plus 3 square root of 3. So I'm going to distribute. I'd have 9 plus 9 square root of 3. Hold on, no minus. -3 times 3 square root of 3 is -9 square root of 3. And then I'm going to distribute here. That would be plus 9 square root of 3. And then distribute here. That would be minus 9 times the square root of 9. Minus 9 times the square root of 9, which is minus 9 times 3. So minus 27. The numerator I'm going to leave alone for now. My denominator, the middle terms cancel out. 9 minus 27. Is that -18? Yeah, I think so. And then you have to check these 3 numbers. This number, and this number. Do they have a common factor? And they do. They're all divisible by 3. So you have to reduce your fraction. So I have negative 5 plus or minus 5 times the square root of 3 over negative 6. And that's my answer to number 17. And that's a lot. I'm so sorry. Then for number 18, I'm going to do the same process. To get rid of this plus sign in the denominator, to get rid of the radical, I'm going to multiply by 4 minus 4 square root of 5 in the numerator and the denominator. I didn't mention on the first one that when I do this, I'm really technically multiplying by 1, so I'm not changing the value of anything. And I am writing this out so I can see what it looks like to distribute. Okay, so I'm going to distribute 3 times 4 is 12, minus 12 square root of 5, and then I'm going to do 4 times 4 minus 4 square root of 5, and then positive 4 square root of 5 times 4 minus 4 square root of 5. Okay, so I'm going to have 16 minus 16 square root of 5 plus 16 square root of 5. And that's going to be minus 16, 4 times 4 is 16, times the square root of 5 times the square root of 5 is the square root of 25. So that's 16 times 5, which is minus 80. So I have 12 minus 12 times the square root of 5. The denominator, the middle terms cancel out. 16 minus 80, is that negative 54? Nope, it's 64, isn't it? 10, 6, 7, 8, yep, negative 64. And then do these 3 terms have a common factor? I know they have 4 in common. So I'm going to divide them all by 4. I hope that's it. So 12 divided by 4 is 3, minus 3 square root of 5 over negative 16. That's the answer to number 18. 19 and 20, I think I'll save those and we'll do them together in class when we get to this assignment. So I'll save these, number 19 and 20, we'll do together. Don't scribble them out. I'll remember that we'll do these together in class. In fact, if you want to write do together, oops, sorry about that. We'll do those together in class. Number 11. The ratio of the length to the width of a golden rectangle is 1 plus the square root of 5 to 2. That's a ratio. It can be written with a colon or written as a fraction. The length of a golden rectangle is 62 meters. The length is 62 meters. What is the width? So I am going to cross multiply. When you do this, you're multiplying these two and these two. So I'm going to have x times 1 plus the square root of 5 equals 2 times 62. 124. Yeah, 124. So I'm going to divide by 1 plus the square root of 5. So x is going to equal 124 divided by 1 plus the square root of 5. I need to rationalize my denominator, so I'm going to multiply the numerator and denominator by 1 minus the square root of 5. Remember, you're distributing. Sorry, that 124 looks so bad. And I'm going to get 24 minus 24 square root of 5 over, oh no, it's 124. See, I didn't even recognize that. 124, 124, and that doesn't look like 124, so remember. And then I've got 1 minus square root of 5 plus square root of 5 minus the square root of 25, which is minus 5. So I have 124 minus 124 square root of 5 all over negative 4. And I believe 4 goes into 124. 3 fours are 12, 31 times, yes. So I'm going to divide, and I'm going to divide by negative 4 to get rid of that negative out of the denominator. So I'm going to have negative 31 plus 31 square root of 5. That would be the width of a golden rectangle that has a length of 62 meters. So width of golden rectangle with length of 62 meters is, and I should put meters beside of this. That's my answer. Okay, moving on. I need to simplify these, and what I have to do first, and this is what you have to think about when you do these, I've got to simplify all these radicals that will simplify. Now notice I didn't highlight the number 2, I didn't highlight 2 or 5 because they will not simplify. So that's the first thing I'm going to do across the board. I am going to write 3 times the square root of 4 times the square root of 2. And then bring down 3 square roots of 2 because I can't do anything with that. For 23, I'm going to write 2 times the square root of 9 times the square root of 2 minus 2 times the square root of 4 times the square root of 5 minus 2 times the square root of 5. And then for 24, I'm going to do 3 times the square root of 4 times the square root of 3 plus 3 times the square root of 9 times the square root of 2 plus 2 times the square root of 9 times the square root of 3. Then what I'm going to do next, I'm going to highlight to show you. I'm going to go through and I'm going to simplify all those perfect squares that I have. I'm going to do that next. So I'm going to have 3 times 2 times the square root of 2. I'm going to have 2 times 3 times the square root of 2 minus 2 times 2 times the square root of 5 minus 2 times the square root of 5. 3 times, oops, see I almost goofed that up. 3 times 2 times the square root of 3 plus 3 times 3 times the square root of 2 plus 2 times 3 times the square root of 3. Then the next thing I'm going to do is I'm going to go through and I'm going to multiply. I'm going to multiply here, 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 and here to make one expression for each of those. So that's going to be 6 square root of 2 plus 3 square root of 2. And then next 6 square root of 2 minus 4 square root of 5, and bring down what did not need to be simplified. And then 6 square root of 3 plus 9 square root of 2 plus 6 square root of 3. Now I am ready to combine like terms. Once you get to here, you are ready to combine like terms. So when I look at this first one, 6 square roots of 2 plus 3 square roots of 2 is 9 square roots of 2. That's the answer. For my next one, I have these two are like terms. And we'll use a different color. Yellow. These two are like terms. So I'm going to combine those. I'm going to have 6 times the square root of 2 because it didn't have anything to combine with. And negative 4 square roots of 5 minus 2 square roots of 5 is negative 6 square roots of 5. That's the answer. Then the next one, my like terms, are this one and this one. So 6 square roots of 3 plus 6 square roots of 3 is 12 square roots of 3 plus 9 square root of 2. That's the answer to that one. Okay, next I'm going to multiply. For the first one, number 25, I'm going to distribute. I'm going to distribute 2 times the square root of 5 times the square root of 6. And then I'm going to distribute, I'm going to put a plus sign, plus 2 times the square root of 5 times 2. Then none of those radicals can simplify, so I'm going to multiply what I can multiply. There's no number outside of the radical here, so I'm going to leave the 2 outside. And then I can multiply 5 and 6 because they're both under a square root. And now for the next one, these two numbers are outside the radical. I can multiply those and get 4 times the square root of 5. And that's my answer. They're not like terms. 30 won't simplify. And then I'm going to go to the next one. All right, so for the next one, I'm going to do the square root of 7 times square root of 7 plus square root of 3. I'm going to do negative square root of 3 times the square root of 7 plus the square root of 3. Square root of 7 times the square root of 7 is just 7. You are welcome just to put 7. So square root of 49, which is 7. Square root of 7 times the square root of 3 is positive square root of 21. Negative 3 times the square root of 7 is negative square root of 21. Negative square root of 3 times positive square root of 3 is negative square root of 9, which is negative 3. These two like terms cancel out. 7 minus 3 is 4. And we won't do the cube root one. You do it the same way you do the first one, but we won't do the cube root one. So you can scribble that one out as well. And I believe I have reached the end. I know this was quite a long video. I'm so sorry. I hope you have a wonderful day.